Hello Maths fans, and we're back with some more help with a Maths Watch assignment. This is to do with rationalising the denominator. That clip if you were to search for that, but this is part of a year 10 assignment I've set, and we're looking at question 14. Okay, so we've got an expression here, 6 plus root 27 over 4 minus root 3, and it has to be, which it's written in this form here. When r and s are both integers, what are the values of r and s? Okay, so we've got an irrational denominator here. Okay, so I'm going to write down here again, 6 plus root 27 over 4 minus root 3. Right, the key part of this is to actually, you have to multiply the denominator and the numerator by something, as we did with the simpler versions of this. But it's this 4 minus root 3, it gives you the clue here. Okay, now, so what you actually multiply by is 4 plus root 3. Now you might think, well, how? Why is that true then? Well, actually what you've got is, if I call that a, and I call that b, root 3, I've got a minus b times a plus root b. Sorry, a minus b times a plus b. Now, if I just do this, let me show you what happens here. A minus b times a plus b. This will always be true, okay? This will always be true. A times a, well, hopefully some of you recognise it, but a times a is a squared. A times b is plus ab. Minus b times a is minus ab, and minus b squared. The two middle terms cancel each other out, leaving us with a squared minus b squared, or difference of two squares. The point is, the result is both a squared, 4 squared, minus root 3 squared. Well, we know if we square a square root, okay, it becomes a whole number. Okay, so for example, root 7 squared is 7. Root 5 squared is 5, and so on. Okay, so that's why this method works. It's basically multiplying the other factor of difference of two squares. So that's why we do it. We now need to have to do it. So let's look at the numerator. I multiply by the numerator by 4 plus root 3 as well. Okay, brackets everywhere, just to make life easier. Now, when you become a bit more accomplished at this, you'll go, oh yeah, a squared minus b squared is 4 squared minus root 3 squared. So that's 16 minus 3, which is 13. Voila, okay, there it is there. But if you don't see that, we can multiply out the long way. Okay, so watch. The denominator here then, 4 times 4 is 16. I'm just doing the denominators at the moment. Okay, 4 times root 3 is plus 4 root 3. I've done everything, multiplied everything by 4 now. Negative root 3 times 4 is minus 4 root 3. And negative root 3 times positive root 3. A negative times positive is a negative. And root 3 times root 3 is 3. Again, can you see, just like we did over here, those middle terms are going to cancel out here. The plus 4 root 3 and the subtract 4 root 3, leaving us with a squared, 4 squared, minus root 3 squared, which is 3. So that's going to give us 13, isn't it, on the next line? I'm going to go down and do that. I'm getting excited now. Okay, so the numerator, we're multiplying out as we would do with algebraic brackets, except we've now got numbers. 6 times 4 is 24. 6 times root 3 is plus 6 root 3. Root 27 times 4 is 4 root 27. Don't worry about that at the moment. We'll get down to that. We're already probably thinking that that could be simplified. And root 27 times root 3, which hopefully is root 27 times 3, which is root 81. Okay, so what do we know here? Well, root 81 I know, that's 9, isn't it? Okay, I'm just going to cross that out and put 9 because I know it straight away. And 4 root 27, okay, so what have I got? I've got 24 plus 6 root 3 plus 4 root 27. Root 27, let's have a look. We're going to have to simplify that, aren't we? Root 27 can be written as root 9 times root 3, which is 3 root 3. So instead of writing plus 4 lots of root 27, I'm going to write plus 4 lots of 3 root 3. I'll put it in brackets. That means we're going to multiply those. Plus 9. Okay, just taking our time here. Just taking our time with this, making sure we're okay. So let's just forget for that now. Let's get this sorted out here. So 24 plus 9 is 33. 6 root 3 plus 4 times 3, which that's 12, isn't it? It's 12 root 3. that is. That bit there would become 12 root 3. 6 root 3 plus 12 root 3 is 18 root 3. Just check I haven't got anything wrong there. Okay, dealt with everything there, good. Over 13. There it is. Cannot be simplified any further because there's no common factors between the denominator and the numerator. Okay, so now we're looking at what's the question asked. It's asked you for the values of r and s. It says r plus s root 3. Let's write it in that r plus s root 3. So that must be r, that must be s, and we've got denominator of 13. So r is equal to 33, and s is equal to 18. Any question that has this sort of format, one part's rational, the other part's irrational, we always multiply by the second bracket, which would be give you the difference of 2 squares. Okay, so if that was 6 plus root 27 over, I don't know, 2 minus 3 root 5, I'd multiply denominator and numerator by 2 plus root 3 root 5, and so on. Okay, I hope that makes sense, and I'll see you next time.